Now we're going to have the continuation of section 1.10, equations of a line. So we're graphing a linear equation using intercepts. So this is part 2 of section 1.10. Graphing a linear equation using intercepts. So when we say using intercepts, we have to know what an intercept is. So we look at an intercept as something that where the line crosses the axes. So if I have the line crossing between the two axes, this is the x-axis, this is the y-axis. So if I have the y and the x-axis, where it crosses the x-axis would be the x-intercept. Now what do we know about that? We've gone out x, but we didn't go up or down. So this is going to be x comma 0. So if we're looking for the x-intercept, we set y equal to 0. So we're going to end up with some form of an equation, a comma 0 or x comma 0, something that would be an x value. Now if I'm looking at the y-intercept, now again on the y-intercept we've gone down but we haven't gone left or right. So the x in this case is going to be 0 and there's going to be a y. So we're going to set x equals 0 in this one, and so we're going to have some sort of 0 and some y value. So y equals 0 for x-intercept, x equals 0 for y-intercept. So this would be the x-intercept, and this would be the y-intercept. So we're going to graph the equation 2x minus 3y minus 12 equals 0, and we're going to find the intercepts. So this is going to be graphing using intercepts. So the first one we're going to do is let x equal to 0. So 2 times 0 minus 3y minus 12 equals 0. So 2 times 0 is going to give me 0. I'm going to add 12 because I want this to give y by itself, so plus 12 to both sides. So this adds to be 0, and I get negative 3y equals 12. You're solving for y, and it's multiplied, so we divide by a negative 3 on both sides, and we get y equals a negative 4. So we have x equals 0 and y equal to a negative 4. So that would make an ordered pair 0, comma, negative 4. Now, what intercept did we say this was? To set x equal to 0, that would be the y-intercept. So it's going to cross the y-axis at negative 4. Now we're going to let y equal to 0. So y equal to 0 is going to give us 2x minus 3 times 0 minus 12 equals 0. So we're plugging back into our original equation, y equal to 0. So this gets to be 0, 3 times 0, and add 12 to both sides because we're solving to get x by itself. This adds to be 0, and we get 2x equals 12. Divide by 2 because it's multiplied, and that gives me x equals 6. So I've got x equals 6 and y equals 0, gives me the ordered pair 6, comma 0. So this would be my x-intercept. So we graph those 2 points on the coordinate plane, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, and we connect the two dots. So there is the graphing a linear equation using the intercept. Give everybody a chance to catch up to that point. Okay, we're going to use a second method on that same equation. The second one is going to be to put it in slope-intercept form. Put equation into slope-intercept form. And graph. Now, slope-intercept is one of those formulas we talked about in the beginning. So we know that slope-intercept form is y equals mx plus b, where b is the y-intercept, so where it crosses the y-axis. And the m is the slope. It's going to be the rise over run in the graph. So I start out with 2x minus 3y minus 12 equals 0 like we did before, but we're trying to solve for y now to get y by itself. So we're going to take a negative 2x to both sides and a positive 12 to both sides. So this adds to be 0, this adds to be 0. We have negative 3y equals negative 2x plus 12. We're solving for y again, so this is multiplied, so we divide by negative 3. So all of these are going to be divided by negative 3. So this gives me y equals negative 2/3 x minus 4. So we have negative 3, so this makes this positive 2/3, excuse me. So this is my y equals mx plus b. So I'm going to graph. My b is going to be a negative 4, so I go down 1, 2, 3, 4 and put a dot. My slope is rise over run, 2 over 3, so up 2 and run 3. Up 2 and run 3. And we get our line, which if you compare the two is the same as what we had before. So give everybody a chance to get caught up to that point. Okay, the next thing we're going to look at is parallel and perpendicular lines. Parallel and perpendicular lines. Now, when we're talking about parallel and perpendicular lines, parallel are those lines that are the same distance apart. So parallel lines would have the same slant of the line. So parallel lines have same slope. The rise over run would be the same in both of them. Perpendicular lines are those lines that intersect in 90 degrees. So that would be perpendicular. So perpendicular lines have what we call opposite reciprocal slopes. So what does it mean to be an opposite reciprocal? Well, an example, if I tell you the slope is 2 over 3, then m perpendicular would be negative 3 over 2. The opposite and reciprocal is this thing flipped over. So we're going to find an equation of a line in point slope form through the point 5, 2, parallel to 4x plus 6y equals a negative 5. So give everybody a chance to catch up to that point first. So the first thing we want to do is put this form into y equals mx plus b, so we can easily find the slope. So I'm solving for y, so I want to bring the negative 4x over. So I get 6y equals negative 4x minus 5. Divide by 6. So I get y equals negative 4 over 6x minus 5 over 6. Now this is my slope, but it's not reduced. So you can see that there's a common factor in common to the numerator and the denominator. So we're going to divide both by 2, so our slope becomes negative 2/3. Now we said we want it to be parallel to. Parallel to says it has the same slope. So that means that our slope that we're going to look for is going to be, in parallel, is also going to be negative 2/3. So now it says that it wants it to be in point slope form. So we have a point and we have a slope. This point's going to be our x sub 1, y sub 1, and we're going to look at our formulas, and we get y minus y1, m quantity x minus x1 is point slope form of a line. So now I plug in y minus 2, y sub 1, negative 2/3 x minus 5. So that's my point slope form of a line. Now, what happens if I want to change this point slope form of a line into standard form? So this y minus 2 equals negative 2/3 x minus 5. I want to change that to standard form. This is point slope. Standard form would be ax plus by equals c. So we're going to take y minus 2 equals negative 2/3 x minus 5, and we're going to change it into ax plus by equals c. So the first thing I want to do is get rid of the fraction. So I'm going to multiply both sides by the 3. As long as I multiply both sides of the equation by the same number, then it's still going to be an equivalent equation. This one then is going to be distributive property. So I have 3y minus 6. Over here, the 3's are going to cancel because you have got 3 in the numerator and 3 in the denominator. They can cancel out to be 1. And then you've got negative 2 times this parentheses, so that again is distributive property again. So I get negative 2x. Negative 2 times negative 5 gives me plus 10. Now, I know in standard form that a has to be greater than 0, and a, b, and c have to be integers. They can't be fractions. So we got the integers part taken care of, but now we have to make sure we put ax on the right side, so on the correct side. So if I add 2x to both sides, that makes the x come out to be positive, the coefficient. So I'm going to plus 6 to both sides. So this gives me 2x plus 3y equals, so that cancels to be 0, 16. So that would be standard form. Okay, give everybody catch up to that point for a minute. So that was an example of parallel lines, but now we're going to have an example of perpendicular lines. So we have an equation of a line through -2, 3, perpendicular to now 3x minus 5y equals 7. Now, when we say equation of a line through -2, 3, perpendicular to, now we're looking at finding still y equals mx plus b. So we can find the m, but we've got to remember perpendicular means opposite reciprocals. So I've got 3x minus 5y equals 7. I'm solving for y, so what do I do first? I minus 3x. So that adds to be 0, and I get negative 5y equals negative 3x plus 7. But I'm still trying to get y by itself so we could put it into slope-intercept form so I can pick off the slope. So I'm going to divide by negative 5 on both sides. So this cancels to be 1. Anything divided by itself. Y equals negative divided by negative is positive 3/5 x minus 7/5. So we want it to be perpendicular to this. So the slope of this one is 3/5. So that makes m perpendicular be, what do you think? Negative 5/3. Opposite reciprocals. So it's perpendicular if we use the slope negative 5/3, and we have the point -2, 3, which stands for our x sub 1, y sub 1. So the first thing we're going to do is we're going to put it into point slope form because we've got a point and we've got a slope. So y minus y1, m quantity x minus x1. So we're going to put in y minus 3. M is negative 5/3. X minus a negative 2. So minus a negative, 2 negatives make a what? Positive, good. So this would be my point slope form. But now we want to put it into standard form. So again, we got to get rid of the fraction by multiplying by 3 on both sides. So this gives me 3y minus 9 equals, the 3's cancel, negative 5x, distributing it in. Negative 5 times 2 is going to give me minus 10. So I'm going to add 5x because I want the x's on the same side with the y's. This makes it positive because remember we said standard form was making it positive. So now I'm trying to get the x's and the y's by itself, so I have to get rid of the 9. So I add 9 to both sides. So this adds to be 0, this adds to be 0. Here we have 5x plus 3y equals negative 10, and a positive 9 gives me a negative 1. So this would be what our standard form is. And let me rewrite the point slope form. So we had y minus 3 equals negative 5/3 x plus 2. So here would be our point slope form, and here would be our standard form. So that was part 2 of section 1.10.